Calculate the equilibrium constant for the reaction iron plus 3 reacting with 3 iodide ions and giving the iron plus 2 and I3 negative. We have the reduction potentials for iron plus 3 2 plus 2 and I3 negative to iodine. Okay, so to solve this question, what we need to understand is there are few things that we need to observe carefully. The first thing is, let's see, the iron plus 3 is converting into the iron plus 2. Okay, so you can expect that this is your what kind, and this is the reduction, right? That's your reduction. Okay, that's your reduction. Okay, so and there is a conversion of I negative to I3 negative. Okay, so what we need to calculate is we have to calculate the equilibrium constant, that is the K equilibrium. We need to calculate it, K equilibrium. Okay, right. So in order to calculate the K equilibrium, we know the formula. What is the formula? Log K equilibrium equals to n E naught cell upon 0.0591, right? 0.0591. Okay, so that is the formula that we need to use it, E naught of cell, right? So what is the value of n? If you see, we need to calculate the value of n, and then there is a value of E naught cell. So let's see the E naught cell, how to calculate the E naught cell. So E naught cell, as you know, that E naught is the reduction potential of cathode minus reduction potential of anode. Okay, so E naught of cathode minus anode, E naught of anode, right? E naught of anode. Now, so you can see that this is the iron plus 3 2 plus 2. It means the reduction is going on, and reduction will be, this is the E naught of cathode. Okay, this is the value of E naught of cathode, and this is the value of, you can say, this is the value of E naught of anode. Okay, this is the value of E naught of anode. Now let's write the values. What is the value of E naught of cathode? That is the 0.77 volt, 0.77 volt minus anode पर क्या है 0.054 volt, right? 0.054 volt. So this value will be the 0.23 volt, 0.23 volt. So that is the E naught cell. All right, this is the value of E naught cell. So one thing is very clear, E naught cell, and this E naught cell is positive also. Okay. Now, another thing is we need to find out what is the value of n in this particular reaction. Okay, so as you can see that there is a exchange. If you write it at anode and cathode, what kind of the reactions that are taking place. So anode, you know, there is a oxidation. Okay, there is a oxidation. So what will happen here is 3 iodide, it will convert into I3 negative, and there will be loss of 2 electrons, right? We know that if there is a loss of electron, there is a oxidation. All right, there is a loss of electron, oxidation, you know, right? Okay, and let's see the at cathode, what is basically happening at the cathode. So if you see the cathode, so cathode, the iron plus 3, right? Iron plus 3 is taking the 2 electrons and it is converting into the iron plus 2. Okay, it is converting into iron plus 2, right? Now how many irons there are? There are the 2 iron atoms. Okay, this ions, 2 Fe plus 3, and here we have the 2 Fe plus 2, right? 2 Fe plus 2. Okay, so that is what Now, so these are the two reactions that are at anode and cathode. So there you can see that there is an exchange of the two electrons. Okay, there is an exchange of the two electrons in this overall cell reaction. Okay, so you can write the value n is 2, and what is the value of E naught cell? That is the 0.23 volt, right, upon 0.0591, right? So solve this value, and whenever you take the K equilibrium, so K equilibrium will be the anti-log of this whole value. Okay, anti-log of this whole value. So once you will calculate the anti-log of this whole value, you will get the K equilibrium. That K equilibrium will be, the value will be, when you will calculate this value, this will be your 7.79. Okay, 7.79, right? This will be your 7.79. So just calculate the value of this anti-log. This will be your 6.26 10 raised to the power 7. So that's how we solve the K equilibrium, right? So the idea is, firstly check the reaction and find out the reduction and oxidation, that is the redox reaction, and then put the formula log K equilibrium equals to n E naught cell of 1.0591. Then figure out how many number of electrons that are exchanging during the cell reaction, that is the 2 in this case, and put the values and take the K equilibrium. Okay, and whenever you take the K equilibrium, you need to calculate the anti-log. Okay, so if you are confused in taking the anti-log, then you can use the shift plus log option in your scientific calculator, and you can calculate the value. All right, thank you.